applications of wireless sensor networks. I have shown in this slide, uh, the wireless sensor networks can be used for wider applications. Means they have variety of applications. Starting with, let's say, transportation and logistics. So this is one area where the wireless sensor network can be used. Then for industrial applications, then precision agriculture and animal tracking, environmental monitoring, urban terrain tracking and civil structure monitoring, entertainment, security, surveillance, healthcare, smart grid and energy control systems, smart buildings, indoor climate control also. So these are different applications where wireless sensor networks can be used. For example, smart buildings. So, as name suggests, what is the meaning of a smart building and how a wireless sensor network be helpful in this or can be used for smart building categories? Starting from the automatic door. If you want to enter into the building, the main gate of the building may open if it observes a particular object is in front of the door. It may open. Then next, if it is a high-rising building, escalators, all the things, lift may be there. So based on some sensing elements, it can sense that, and then it can control the operation of each and everything present inside the building. Control of AC, control of TV, everything. So in these cases, wireless sensor networks can be used. The theoretical aspects of the application. I'm not discussing how these wireless sensor network can be placed, what type of algorithm can be used for, let's say, tracking purpose. Tracking, it may be done in case of military application as well. Okay, so anywhere tracking is required. In transportation systems, tracking can be done. So how a wireless sensor network be helpful for tracking a particular object? And then tracking, not only the tracking, the identification of particular object, tracking as well as identification. So in this way, you can theoretically describe different application areas of wireless sensor network. Now, these networks are used in environmental tracking such as forest detection, animal tracking means the different types of animals present in the forest and where they move means what is their nature, etc. etc. Then flood detection, forecasting, and weather prediction. Also, these network can be used in commercial applications like seismic activity prediction and monitoring. They can also be used in military, so military applications such as tracking, environment monitoring, and surveillance applications. Okay, so the methods I am not asking means how they can be used in the military application. So these sensor nodes from sensor networks are dropped to field of interest and are remotely controlled by the user for tracking, environment monitoring, surveillance application, etc. etc. So in the military application, the tracking may be tracking of enemy. Security detection can also be performed by with the help of this network. In healthcare industries, the doctors may take help of wireless sensor network for tracking and monitoring of patients. Okay, out of these applications, the most frequently used wireless sensor network application is it is in the field of transport system such as monitoring of traffic, dynamic routing management, and monitoring of parking, etc. Rapid emergency response, industrial processing monitoring, automated building climate control, ecosystem and habitat monitoring, civil structure health monitoring, etc. Okay, so these networks means wireless sensor networks may be used in the other areas. Correct. Now, I will touch something in brief. The first one is the target detection and tracking. Suppose we want to detect a particular target and we want to track it, means how the target is moving. What kind of target is, that is the detection. and where it goes, means which type of contour it is following. So that is the tracking of the object target. The application of wireless sensor networks to the problem of intrusion detection and the related problems of sorting and tracking targets are of great significance to computer and telecommunication systems. This is the fundamental, means the interesting problem we can say. So in general, target detection and tracking is well recognized discipline. There are numerous proposed solutions in the literature that rely either on expensive and specialized sensors or on simple and inexpensive schemes and tools. Actually, this is the method by which we can do it. Uh, we can do the target detection and tracking with the help of some expensive and specialized sensors, where the technique definitely is expensive, means, but it may have several advantages as over this inexpensive schemes. So in case of inexpensive, sensors are very simple, they are cheap, the algorithm used to detect the target object and track it, the algorithm, they are also simple. Okay, so that's why there are two categories. Based on these two, we can perform the target detection and tracking. So these are the theoretical aspects of these schemes we are discussing. Means how theoretically we can detect a particular target and track it. Otherwise, mathematics is involved behind it. I'm not going to discuss that mathematics. The only theoretical part I am discussing here. So in case of inexpensive schemes and tools, in these approaches, the latter means these approaches are appealing for scalable target detection and tracking purposes. Uh, we know that the tracking with inexpensive wireless sensor network has its own challenges, including difficult signal processing, because the sensor networks algorithm, they are the less expensive. So that's why definitely challenges will be more associated with this type of target and detection schemes. So difficult signal processing, synchronized decision making, multimodal sensing, high frequency sampling, and data synthesis. In fact, being a communication engineer or computer science of students, you can imagine that if we want to detect a particular target, if we want to track that particular target, what is involved here? Definitely, if you want to track, so for tracking, visual input may be there, means some camera may be there, that camera will produce huge amount of data, and a strong processing algorithm so that we could manage the tracking of the object. So that's why these difficulties will be involved in this case of the later scheme, means inexpensive sensing. Okay. A lot of research is available in literature. In your book, you may see different schemes are available. Different researchers have shown uh, that the tracking detection will be can easily be done with this particular scheme, with that scheme, so on and so on. So a lot of research is available. So I have selected few topics from the available literature. So some researchers have relied on simple threshold-based schemes or use extra hardware on each small sensor device to carry out the related complex signal processing operations. Target detection and tracking. This is the important things related to a communication engineer. Okay. So we are discussing about this particular scheme. So for target detection and its tracking, we may use two types of algorithm. One is expensive, second is inexpensive. So inexpensive schemes, they have several challenges, as I discussed. And what is available in literature that I am discussing related to target detection and tracking. So some researchers, what they said, कि if we apply or take help of simple threshold based scheme. What is the meaning of threshold based scheme? In layman language, see, if we take some data and if we process this data, after processing the data, we will give some results. Okay, the result about the detection of a target, result about the tracking of an object. So based on some threshold based scheme means at the detection, if we say the available, for example, it's not the hard and fast rule, but for example, if we say at the output, if we say the output power or output voltage is this one above this particular value, then that type of object will be detected. We will say the detected object is this one. If it is below than that, we will say detected object is this one. If it's below than this one or lies in this range, then object may be this one or nothing is present. So in this is the meaning of a threshold based, okay, threshold based scheme. So if we the researchers, they relied on simple threshold based scheme, or if they use extra hardware to decide for a particular object or to decide tracking of object. Okay, so these schemes, they definitely have the potential of lowering valuable sensor data. Why? Because as I said, if camera is there that is tracking particular object, so a huge amount of output means output of camera will give you huge amount of data. But threshold based scheme, because we put threshold, so that will definitely lower the valuable sensor data. If I say the output voltage should be this one, so data that is coming from the camera, the entire data will not be useful. The data related to that produces output voltage of a particular value will be selected by the scheme. Okay, so that's why I'm saying in this case, the potential of lowering valuable sensor data will be there because it will lower the valuable sensor data and hence may not be adequate for low signal to noise ratio wireless sensor environment. Uh, what does it mean? It means that if at the output we have some signal power, so always noise will be present in the system. So because of this, the noise will also be present. So signal to noise ratio or signal to noise power will be available at the output of wireless sensor network. Now, if we put a threshold, key after this value, we will say the object is detected, and below this value, nothing is detected. So in case of low signal to noise ratio, when noise power is more and the actual signal power is less, this scheme may not work. So that I want to say. Okay. So based on this particular scheme, where the researchers rely on threshold-based scheme, or they use extra hardware on each small sensor device to carry out the complex signal processing operations. This technique, they have capability to lower the valuable sensor data, hence may not be adequate for low signal to noise wireless sensor environment. But that scheme can be used, but it can be used for the cases where signal to noise ratio at the wireless sensor network is large. When it is low, it cannot be useful. Of course, it is possible to add particular purpose hardware to alleviate these problems. Means we can use additional hardware to suppress the noise power so that we can boost the signal to noise ratio. Okay, but this will add the cost and energy consumption of such cell forward and low cost means. Definitely by adding more hardware, more energy will be consumed, requirement of energy consumption will be more, and cost will also increase. But what we are discussing, inexpensive scheme. So that will not be the inexpensive. Okay. So this is the problem. Now, among the major applications of wireless sensor networks are intrusion detection, target detection, classification, tracking, and localizing. This is the theoretical things. Okay. I'm not discussing the mathematical thing because if I start discussing the mathematical things, then It's very difficult to definitely. I hope that it will be very difficult for you. So that's why I am trying to make it simpler. Only the theoretical things, how we can detect, how we can track the object, what are the schemes present in the literature, which one is based, which one is not. That's why. The low cost of sensor node make it realistic to set them up in large numbers over huge area, and thus such devices have turned into capable contenders for tracking the distributed detection, categorization, and tracking problem. There are several works on target classification in WSN that are based on centralized techniques. This usually entails pattern recognition, matching via time frequency signature generated using various kinds of targets. For example, one researcher named Caruso Vithan Wasam, they illustrated a centralized vehicle categorization system via magnetometers based on similar magnetic signatures generated by using various sorts of vehicles. This work entails a high computational load on each sensor node. It also requires considerable layout and management over the environment. Moreover, the vehicle has to be driven straight over the sensor for precise categorization. On the other hand, at arbitrary directions and distances, the method can only sense the presence of the target. Now, the threshold based is one scheme. So, what will be the advantage, disadvantage we have seen theoretically? Now, another scheme is given by this particular researcher. Uh, it is based on the centralized vehicle categorization. So, what they did, they used this scheme and they find that the categorization of object can be done via magnetometers based on similar magnetic signatures generated by using various sorts of vehicles. So while moving the various vehicles, the data is recorded on the magnetic strips. Okay, and different algorithms are used in this. So to detect the object, to track the object, and for categorization purpose as well, means which type of vehicle it is, small vehicle, medium, or large vehicle. So what they observed that for these the magnetometer based magnetic signature vehicle, if the vehicle has some arbitrary direction, arbitrary movement, it cannot be observed. Only the presence of vehicle can be detected. So with this scheme, this type of observation we can have. Then another scientist, a researcher, Aurora et al. Actually, Aurora et al. Means there are several researchers associated with Aurora. They have published their own work. Okay, so that's why I quoted Aurora et al. They have considered a surveillance application scenario. It is termed as a line in sand. The aim of this setup is to recognize a violation within region. The interfering target may be maybe an exposed person or a soldier carrying ferrous weapon or a truck. So to detect that particular of target, they have carried out their research. Okay, the major basis user requirement of this function means they carried out the research. What are the requirement of the basic user requirement of this function they carried out? First was the target recognition. Second, categorization. Third, tracking. These are the functions. Okay, the user enumerates the quality of service metrics that influence the way in which the system can detect, classify, and trace the target. The detection process has to distinguish between a target's present and non-existence. Winning detection necessitates a node to accurately access a target's existence while avoiding fictitious recognition in which no object are in existence. The major performance measures for detection are probability of accurate detection, probability of false detection, acceptable latency between target existence and its final recognition. So based on his research, what they observed, what they measured, first the probability of accurate detection. Uh, they detected some vehicle and then they decided what is the probability of accurate detection. Number of times, suppose vehicle is a small vehicle like car. They detected sometimes car, sometimes medium vehicle, sometimes large. Then computed the probability how many times car has been detected correctly. So if the probability of detection is very high or very low, then scheme will be this will work satisfactorily. So probability of accurate detection, it should be high or low. It should be the static detection just like always yes. Okay, but not always yes because some randomness is there. So it will be very high. Okay, probability of detection should be very high. Then the probability of false detection, how many times it detected the wrong detection. So that is the false detection. False detection, car is there, but it is detecting something else. Sorry, the car is not there, but it is detecting the car. So that is the probability of false detection. Means the correct object is not present, but the algorithm is detecting the correct object. So this is the false detection. So the probability of false detection must be as small as possible. And then acceptable latency between target existence and its final recognition. Means the distance between the existence and recognition. So that is the acceptable latency. Okay. So based on these parameters, the performance of algorithm can be judged. So this is another algorithm for detecting a target and tracking the target. Uh, then in classification, the target has to be identified as belonging to one of several categories such as vehicles, soldiers, tree, and animals. Okay. Now, after detecting the object, tracking it, there must be the classification of the object. Means which type of object it is. So for that, some classification algorithm we used. Okay. So in this case, what algorithm will decide the category of vehicles? Means it is category of vehicle means which type of vehicle it is. Then whether it is vehicle or something else like soldier, tree, animal, whatever is there. So furthermore, classification relies on approximation where the pertinent parameters of sense signals such as its power density, period, duration, amplitude, phase, and bandwidth are estimated. The main performance measures of the classification processes are the probability of correctly classifying the ith class, probability of error in classifying the ith class as the jth class. Means if I am saying the classification ith class belongs to, let's say, vehicles, jth class belongs to animals, kth class trees, and so on. So, what is the probability of correctly classifying it? And what is the probability of error in classifying the ith class as jth class? So, based on these metrics, the performance of algorithm we can judge. So theoretically, we can say for detecting an object and for monitoring an object for classifications, various algorithms may be used. Okay, and I'm not discussing about the algorithm itself. Okay, so then these algorithms means this type of algorithm we are using, whether they are the first category means expensive or inexpensive. And in expensive algorithm, what is present in the literature means how many algorithms are present. So I am not discussing about number of algorithm present, but briefly about the expensive algorithm, what it does and what inexpensive algorithm does. how we can classify the object, how we can detect the object, how we can track this, how we can classify this, on what basis we can do it, what are the performance metrics. Okay, and if these performance metrics, if we want to improve the performance, then definitely we will move from inexpensive to expensive types of methods. So this was just one example that was related to uh, the identification of target and its tracking. Correct. So similarly, please see the applications in each and every area. As I show, oh, as it is mentioned here, different application areas means industrial applications. So please look at this particular area. In industrial applications, how wireless sensor networks can be applied, can be used, can be helpful. The tracking entails keeping on the target's position as the target moves in the area covered by the wireless sensor network's area of coverage. In order to have a successful tracking process, the system estimates the target primary point of entry and recent position are within the acceptable detection latency or not. Means to track this, correct? So there are several design considerations that need to be considered when designing a wireless network sensor network for target detection. So to detect a particular target, we must be careful. We must take care of the following considerations. So what are these considerations? Number one, the energy, dependability, and complexity.